There is a cable on the floor of the Atlantic Ocean right now, roughly the diameter of a garden hose. And at this exact moment, it's carrying a substantial portion of everything happening on the internet between Europe and North America. Not a satellite, a cable, sitting in complete darkness for kilometers underwater, doing almost all of the work. Around the world, 532 of these systems are active today, and the overwhelming majority of people who use them have never once thought about where their data actually goes. That changes now. $9.47 trillion moves through submarine cables every single day, not every year, every day, which means the architecture of the global financial system runs on glass fibers at the bottom of the ocean. Let that sit for a second. These cables carry more than 95% of all intercontinental data. Every email, every video call, every streamed episode of anything the moment it crosses an ocean. That's a cable doing the job, not a satellite. Total cable length sits between 1.4 and 1.5 million kilometers worldwide, enough to circle the Earth roughly 35 times. Andy Champagne, the CTO of Akamai Labs, put it plainly. If you have emailed, texted, or video chatted with someone on another continent, you've used a subsea cable, likely without giving it a second thought. What follows is that second thought. A submarine cable is not a wire. Calling it one undersells the engineering by a wide margin. 9 distinct layers make up the finished product. Starting at the center with ultra-pure silica glass fibers no thicker than a human hair, carrying data not as electricity but as pulses of laser light. Signal loss across a full kilometer measures only 0.15 to 0.17 decibels, which is almost nothing over the distances these cables cover. Working outward from that glass core, a stainless steel strength member, a copper conductor, polyethylene insulation, an aluminum water barrier, steel armor wires, a nylon antar wrapping, and an outer polyethylene jacket. Deep water sections end up about the diameter of a garden hose, while nearshore sections run heavier, closer to wrist width, because shallow. Coastal water is where most damage actually occurs. Every 50 to 80 kilometers along the cable sits a repeater, a metal canister weighing over 250 kilograms, amplifying the light signal directly without converting it to electricity first. Powered by high-voltage DC current sent from shore stations on land. That technology has been running since 1995. Put it all together and modern cables carry over 200 terabits of data per second, with capacity growing roughly 40% per year for 4 consecutive decades. Dover to Calais in 1850 was the first commercial submarine cable, connecting England and France, and 4 years later, an American merchant named Cyrus Westfield decided the Atlantic itself was next, forming the Atlantic Telegraph Company in 1856. What followed consumed years, wrecked equipment, and humiliated some very confident people. The 1857 attempt ended when the cable snapped entirely. A second attempt, in 1858, nearly lost it 3 separate times, 2 storms, before it finally reached from Valentia Island in Ireland to Trinity Bay in Newfoundland on August 5th. Queen Victoria's 98-word congratulatory message to President Buchanan arrived 11 days later after nearly 16 hours in transit, traveling at approximately 0.1 words per minute. 3 weeks after that, the cable was dead. The chief engineer, a medical doctor by training and not an electrical engineer, applied around 2,000 volts to the line while trying to boost the signal and destroyed it entirely. 8 more years passed before the first permanent transatlantic cable went live on July 27, 1866. By 1988, the fiber optic cable, TAT8, built jointly by AT&T, France Telecom, and British Telecom, was moving 280 megabits per second across the same water. From 0.1 words per minute to 200 terabits per second, roughly 160 years separate those two numbers. Somewhere in the world, a submarine cable gets damaged 3 to 4 times every week. And about 80% of those incidents trace back to human activity. Fishing boats dragging trawl nets across the seafloor, or ships dropping anchors in the wrong place. Repairs run around $2 million per incident and take 3 to 5 days when weather cooperates. February 2024 showed how concentrated the damage can get. Cables AAE-1, Seacom, EIG, and TGN were all severed near Yemen in the Red Sea, cutting internet service to more than 100 million people across West and North Africa in a single event. 9 months later, 2 Baltic Sea cables went down, Finland to Germany, Lithuania to the island of Gotland, with a Chinese cargo vessel called the Yipeng 3 drawing suspicion. Back-to-back incidents on 2 separate seas inside 1 calendar year pushed the United Nations to act. And on November 29, 2024, the ITU launched the first-ever international advisory body for submarine cable resilience. The internet carries a quality of weightlessness in most people's experience of it, something ambient, something that doesn't seem to have a physical address. But the physical address exists, and it's mostly on the floor of the ocean, running through glass fibers inside a cable no thicker than a garden hose, with nothing overhead except kilometers of dark water and the occasional trawler dragging nets across the seabed. Queen Victoria's message took 16 hours to cross the Atlantic at 0.1 words per minute, through a cable that survived 3 weeks before a doctor with too much voltage killed it. Today, more than 200 terabits per second cross the same water sitting quietly out of sight, doing the work the modern world depends on entirely. Most people will go their whole lives without thinking about it once. Now you've thought about it.